Hi, my name's Adam, and I'm going to go over the fracture mechanics of wood and the possible improvements using coatings, layers, and grain direction. My proposed outline is a background and some motivation for my project, the fracture mechanics of wood, some research improvements, my experiment, my results, and my conclusion recommendations. The motivation for this application is a piece of wood is used in target practice, which often fracture to the point to failure, and I want to aim towards prolonging the life by possible improvements. The fracture mechanics of wood are difficult. It's a non-homogeneous material compared to other engineered materials, and it's often hard to measure the crack length for the formulas. The process zone can also be difficult. In order to assume linear elastic fracture mechanics, there's two approaches, and there are defects like any other engineered materials, shakes and checks, which are cracks along the grains, and knots, which are areas of large stress concentrations. There's also toughing mechanisms in wood. Plastic deformation and microcracking are energy spent not towards propagating the main crack. Crack bridging, which are fibers that still hold on to each other and bridge over the crack, making it harder to propagate. And weak interfaces, that the tensile stresses in the crack will make the interface separate, blunting the crack, rather than a strong interface just going right through as if it's not there, as seen on the right. Some research improvements were moisture content and dry history. The added moisture up to 18% can improve fracture energy, and drying it will decrease it. There's an application where a soft material was used on a brittle material in order to absorb most of the impact from a high impact scenario. A non-adhesive layer that was shown that layers that are not attached to the actual subject itself could initiate the bullet to expand before it hits the surface, causing more damage. For particle board, you can add more resin, up to 8%, and that'll improve the fracture energy. Above that, it'll start to decrease. And the grain direction. Have you seen from chopping wood, you never chop a wood perpendicular to the grain, you chop it along the grain. It's easier to split. For my experiment, I first shot at the knots, which are the high stress concentration areas. I then shot at a clean area of various types of wood, and then once observing, I tried possible improvements on the best choice. These are my results that it came up with. The particle board turned out to be the least indented volume, which is directly correlated to hardness, and also showed no cracks on entry, which is a direct correlation to the fracture toughness. So the best piece of wood that for this application would be the particle board. Below is an examination of shooting along the grain. You can see that the indented volume is better than any of the other pieces of wood. The only thing that makes this experiment hard is that wood doesn't come against the grain. It doesn't come like that, so it's hard to consistently hit the grain. This is just an examination of this. Once the particle board was determined to be the best suited for this application, I then did modifications to it. It turns out that the packing tape improved the indented volume by half of what it was, making this the best modification. And it was shown that the knots were confirmed to be the high stress concentration areas. The cracks were extensively longer here than they were on clean areas. The green handled the knots the best, while the white, the stress concentrations were too much and the cracks propagated through the piece of wood. There are some limitations, as I assumed a lot of things for my calculations. It was hard to measure the cracks because of the microstructure. And, shooting, though I shot close to the areas I wanted to, most of the shots were good, but not perfect. My conclusion is, if you're going to choose a natural piece of wood, you would choose the green wood. This had the least amount of damage, and you would choose a piece of wood that had no shakes or checks. If you did, you could cut them off. And you want to minimize the knots, especially near the edges where catastrophic failure could happen. And if you were to choose any kind of piece of wood, particle board would be the best. It would reduce the impact volume if you use packing tape on it also. These are my references, and this is my presentation. Thank you.